Okay, now we're at step functions, and I am going to kind of give you an overview of that, and then we're going to do a word problem having to interpret the step function, and then we'll be done with day one. Okay, so special type of piecewise function that looks like steps. So the graph is going to look like steps. So notice that when we see this graph, or this equation, that all of these are just numbers, okay? So what that means is it's gonna look like this one did when it was just a number. So 15 is just a number. That was a horizontal line. So we're gonna have a bunch of horizontal lines, which is why it's called a step function. It's also called a greatest integer function here. Okay, so we have an idea in our mind. We're going to have horizontal lines. What I'm going to do is still make those tables so that we get practice in that, and it just helps with keeping track of everything. But eventually you may get to the point where you don't have to make a table for a step function. But I always want to see a table for the other ones, okay? So -4, this is technically y equals -4, and I have an xy. And this just helps with keeping track of my open and closed and where everything goes, okay? So we are going to start at -5. Notice something else where the next two restrictions, this has 3 pieces, and the next two are between two numbers, okay? So you're going to see a little bit of a difference there. You're not going to have arrows. So -5, and this is just less than -5, so we should have an open circle. And then we want numbers less than -5. So remember, negative numbers, -6, -7, those are all going to be less than -5. So I have -4, -4, -4, because there are no x values to plug in, so all of my y values are the same. Okay, now for the next line is y equals 1. So x, y, and I'm going to start at -5. I'm going to pick a value in between -5 and -1, because -1 is my other stopping point. So I'm going to pick -3. At -5, I have an equal to sign, so I'm going to have a closed circle there. At -1, I have no equal to sign, so I'm going to have an open circle there. And then my y values are all 1. And then for my last line, it'd be y equals 7. So I'm going to start at -1, and I'm going to end at 4, and I need to pick a value in between, so I'm going to pick 2. At -1, I have an equal to sign, so that's going to be a closed circle. And at 4, I have no equal to line, so it's going to be an open circle. And all of those values are going to be at 7. Okay, so I'm going to go ahead and graph this. So the first one was y equals -4, so I'm going to be at -4, and it's starting at x equals -5. 1, 2, 3, 4, 5. And 1, 2, 3, 4. This is going to be an open circle at -4. That's my y value. And then I have -6, -7. All of those are at a y value of -4. And that one goes on forever. Next one is at y equals 1. And at x equals -5, y equals 1, that's going to be a closed circle. At -3, I'm at 1, and at -1, I'm at 1. Oops. That's why I do this. I'm going to have an open circle here to remind myself. That's why I put all those there. And then I'm going to connect these, and there is no arrow because it's restricted between -5 and -1. There's no open interval. And the last one's at 7. So at -1, I'm going to go up to 7, and that's going to be a closed circle. And then at 2, I'm going to go up to 7, and at 4, I'm going to go up to 7. Oop, again, I messed up. It's okay. At 4. That's why we use pencil. And then I'm going to connect those. Notice that there is no gap between each breaking point. It jumps straight up to the next one. So there's no gap left and right. And there's an open circle below every closed circle. Okay? So you can't have 2 closed circles, one on top of the other, because that would not pass the vertical line test. You'd have 2 different outputs for that same input. And then we don't have any x values. Like if I had an x value of 10, that would not be in the domain of the function because it's not defined for the function. It doesn't go out here anywhere, okay? So out here, those are not part of the function, okay? All right, so let's interpret a step function in this graph here. Okay, so Center High School held a 4-hour fundraising pledge drive. The students organizing the drive counted the total money raised at the end of each hour. The results are shown in the graph below. So let's look at the graph for a second. Okay, so it's counted at the beginning and it's at 0. I'm not counting it as it comes in. I'm only counting it at the end of each hour. So at the end of hour 1, I notice that it has jumped up to 400. So it's not that I haven't made any money between this point, I just haven't counted it. So it's not on my graph. Okay, so that's just kind of where we're at here. So how much money had the students raised after 2 hours? So after 2 hours had passed, I'm gonna go up here and my closed circle is up there. So that means I've raised $1,000 after 2 hours. And this is cumulative, okay? How much did they raise in all? So the furthest to the right is at 4 hours, and my tallest or my highest point on the graph is at 1,800. So they raised $1,800 in total. Okay. What is f of 3.5? So remember, this is that function notation. F of 3.5, that's my x value. So down here, 3.5 would be here. So I'm going to go up to 3.5, and I'm on this line. So after 3.5 hours, I haven't counted again, so I'm still on that line. And that looks like it's between 14 and 16, so I'm going to call that $1,500. Okay, and I would recommend that you pause the video before and try to answer these questions before I go ahead and do it, just to give yourself some practice. Okay, so on what interval does f of x equal 400? So now it's asking for something else. I don't know what x is, and I'm looking and I'm given what y is. Okay, so it's asking what interval is f of x 400. So here is where f of x is 400. So I need to know my x values where that is true. So between those two x values. Okay, so x's are going to be greater than or equal to 1 because I've got a closed circle. So greater than or equal to 1 and less than 2. So between 1 and 2. And then our domain. So remember, domain, that is your inputs. Domain in, those are your x values. Okay, so I'm looking for what x values does this hit. And so I'm including 0, and I go all the way to 4, and there are no more x values after 4. Okay, all of the x values in between are defined though. So x's are greater than or equal to 0 and less than or equal to 4. Then the range is my y values. Okay. Now my y values are at 0 and they go up to 1,800. Okay. So is it y between 0 and 1,800? Well, this is where it gets a little tricky. Because do I have a value at 200? Is there any line there? No. What about in here? Any lines here? So if I look at it that way, there's only a few Y values that it's hit. I've only counted the money a couple times. There's not a diagonal line, so I can't just say between these two values. I have to list which values it actually hits. Okay, so what I'm going to say is I'm going to use a set. So this is our set notation. Just like when we have that curly bracket at the beginning of this function. So in the set, I'm going to hit this Y value of 0. I'm going to hit the Y value of 400. This Y value is 1,000. This one is 1,500 and 1,800. And so that is the range of this graph. Okay, give your homework a shot and let me know if you have any questions. So you should be working on section 1, day 1 worksheet, that first one in your packet.